Hey Team 6-1, this video is on thermal energy, temperature versus heat. By the end of this video, you should have a better understanding of thermal energy, as well as the difference between temperature and heat, as demonstrated in the notes in your interactive notebook. Before we get started, you need these two pages. The first on the left is the thermal energy reading. It's a half sheet. The second page has the picture of a beaker and a thermometer and fire, and of course a pencil. And it's titled Thermal Energy. So if you have those things, and of course your interactive notebook. So if you have those things, let's begin. Before I get into the reading, I want you to understand these three pictures. We can separate things into either gases, liquids, or solids. And they have these particles. They're all made out of particles. And so I want you to understand that the particles in a gas, they have so much energy. They're kinetic energy, and they're just vibrating back and forth, and they fly all around, and they do not take the shape of a container. Liquid, the particles in liquid have less energy. They're still vibrating back and forth, but they take the shape of the container they're in. And as they are vibrating, they move and slide freely past one another. The particles in a solid, they are just standing so close. They are like so close together, so close to one another, that they are just kind of shivering together. So it's kind of weird to think about, let's say the pencil in your hand is made out of particles, and these particles are vibrating back and forth, but they're so packed together that we can't see them moving, and they do not take the shape of a container. So you could stick a pencil in a container and it's still going to stay a pencil. All right, now I'm going to get to the reading, and I think maybe this will make more sense to you. All right. Thermal energy plus temperature versus heat. As you know, all matter has energy, and there are different types of energy that we encounter on a daily basis. All matter is made up of particles called atoms and molecules. These particles are in constant motion. They vibrate, rotate, or move from one place to another randomly. Since these particles are in motion, which type of mechanical energy do they have? If you answered kinetic energy, that's correct, because they're moving. Kinetic energy is the energy an object has due to its motion. Water molecules have kinetic energy because they are freely flowing. When you boil a pot of water on the stove, energy is produced. This energy is called thermal energy. The prefix therm means heat. Thermal energy is the total amount of kinetic energy contained in all the particles of a substance. The greater the kinetic energy of particles in the substance, the more thermal energy the substance has. However, thermal energy also depends on the number of particles in a substance. More thermal energy does not necessarily mean a higher temperature. For example, the ocean, because it's so huge, has more thermal energy than a pot of boiling water. When scientists measure temperature using a thermometer, they aren't necessarily measuring how hot or cold a substance is. They are actually measuring the average kinetic energy of the particles in the substance. The more kinetic energy the particles have, the higher the temperature of the substance. This is different from thermal energy because temperature is not affected by the number of particles the substance contains. So what about heat? Heat is the transfer of thermal energy between substances that are at different temperatures. Energy is always transferred from the warmer substance to the cooler substance. For example, if you hold a hot cup of cocoa on a cold day, the heat from the cocoa transfers from the cup to your hand. The cold doesn't travel from your hand to the cup. And that's why if you get an injury, then you want to put ice on it, because it's going to, that that hurt, that heat, because it usually gets hot and swollen and infected sometimes, and so that heat will transfer from your body to the cold ice pack. All right, you need to get this paper, and you're going to cut around thermal energy. That's why I drew kind of a circle around it. I know it's not kind of a nice circle, but it's a rounded off circle there. So you need thermal energy because you're going to glue that into your notebook. You need to cut out the beaker, so cut all the way around it. In the center, you're going to cut all the way around that heat versus temperature, and then cut on the dotted line for that flap, and then you're going to cut around the writing. You're going to glue your reading onto page 52 of your interactive notebook, and then we'll be gluing the other pieces on page 53. So once you have your materials, you can go ahead and get started. Thermal energy is going to be glued at the very, very top, and then your beaker is going to be glued underneath, and you want to make sure that you have a flap underneath your beaker because we're going to write some things underneath it. And I want you to also take some notes. The heat versus temperature, you're going to just glue on that little tab on the left-hand side, and then temperature, that little flap should come up, and heat, that little flap should come up. Your writing then will go on the bottom. Okay, so looking at the notes, again, if you need to pause so that you can get some of this work done, go ahead and pause. But on the beaker, you're going to write the total amount of kinetic energy contained in particles of a substance. And then you can draw those circles with arrows coming out because those show the particles in motion. Remember that we were talking about water, so this would be liquid, so they would not be flying out of the container like I showed you earlier, as in a gas. I think when you're ready, you can continue on. Underneath your beaker, I would like you to write the prefix therm equals heat. And underneath that, the greater the kinetic energy equals greater thermal energy. And also depends on the number of particles in a substance. Again, feel free to pause so that you can see that on the video and get that written down. On the right-hand side, underneath temperature, how do we measure temperature? We use a thermometer. It is the average kinetic energy of particles in a substance. And again, the greater, so it's an arrow up, kinetic energy, the greater the temperature. Underneath heat, heat is the transfer of thermal energy. And again, I want you to remember that heat moves. Cold does not. Okay. For your writing, it says to explain what thermal energy is and use real-life examples to support your explanation. So thermal energy is a type of energy that causes heat. It is the total amount of kinetic energy, motion in substance particles. For example, boiling a pot of water increases the kinetic energy in the water, which also increases the thermal energy. Again, when you have that written down, then you can continue on. Here is another look at what your interactive notebook should look like on pages 52 and 53. Just like last time, I want to give credit to this lady who created this reading and the work for your interactive notebook, and so thank you, Jay Smith. I just took your materials and made a video for my students. So thank you again. My students are Red Hawks, so go Hawks!